Good evening, Kritika. Good evening, Pritika. We'll begin the class in a while. Hold on there, I'll begin the class in a while. Okay, so it is 7. It is already, I don't know what is the time. It is already 7:08. So, good evening, Suraksha. Very good evening, Suraksha. I'll begin at 7:10. So, let me do an interesting thing at first. Then I'll move into the chapter. Okay. So, should be coming a little bit. Okay. Let me draw a magnesium atom. Okay. And when I have drawn the magnesium atom, let this magnesium atom be bonded on 4 sides, okay, with nitrogen. These nitrogen are the member of a ring. These nitrogen are a member of a 5-carbon ring, like this. Okay. And here it will be So let this be the member of a 5 carbon ring in from the 4 sides. This is ring number 1, this is ring number 2, this is ring number 3, this is ring number 4, and this is ring number 5. Okay, what you are seeing in the structure is, you are seeing a magnesium atom which is bonded to 5 carbon ring. A magnesium atom which is bonded to 4 nitrogen, and these nitrogens are actually, if I draw it outside, nitrogens are actually a part of a 5 carbon ring. You getting my point? A part of a 5 carbon ring. 1 carbon, 2 carbon, 3 carbon, 4 carbon, and 5 membered ring. No, sorry, not 5 carbon, 5 membered ring. Such a ring where there is CH3 here, there is CH3 here, there is CH3 here, there is CH3 here, and this is N. Such a ring is known as a pyrrole ring. So ring number 1 is a pyrrole ring, ring number 2 is a pyrrole ring, ring number, is it so? Is it buffering for other people also? Please let me know. Is it buffering for other people also? Please let me know. Okay. Siddharth, I think your net connection is weak. Okay. Now, as I was saying, that this magnesium is related to the what we can say 4 nitrogen. The nitrogen which is a part, valency of nitrogen is 3, 1, 2, 3. Okay, so from here you create the pyrrole ring, and this is related to the magnesium. This magnesium is this, and related from like this. So what chemical structure you are showing? Okay, fine, I'll tell you. But this 5th ring, ring number 1, ring number 2, ring number 3, and ring number 4 are called pyrrole rings, and all are pyrrole rings. Okay, but you see, the ring number 5th, the ring number 5th and the ring number 5th that you are seeing, this ring number 5th is a cyclopentane ring. The ring number 5th is a cyclopentane ring, because this is not a pyrrole ring. This is a normal cyclopentane ring. Because when you will call it pyrrole ring, okay, you will call it pyrrole ring if there is nitrogen and then the ring is there like this. Here C, here C, here C, here C, and here N. Then it is known as a pyrrole ring. Okay. Then it is known as a pyrrole ring. Remember that. But if it is normal, then it is a cyclopentane ring. So you see this structure. Magnesium is bonded to 4 nitrogens from 4 sides. The nitrogens, which are actually a member of a pyrrole ring. Okay, nitrogen, which is actually the member of a pyrrole ring, it is bonded like this. Now this is known as a tetrapyloric head. This is known as a tetrapyloric head. This is a tetrapyloric head. And with this tetrapyloric head, if I again draw the tetrapyloric head like this, Mg, N, N, with this, and this is the 5th ring, which is the cyclopentane ring, here another pyrrole ring, and here another pyrrole ring is there. Okay, so with this 1 2 3 4 pyrrole rings, 1 2 3 4 pyrrole ring, and fifth tetra what to say, fifth cyclopentane ring. This is a tetrapyrrolic ring. Okay, now with this tetrapyrrolic ring or this is the tetrapyrrolic head. So this is the tetrapyrrolic head. Now if you see this tetrapyrrolic head, okay, with that from here arises a tail, a long tail. This tail is made up of simple CH3, CH2, CH2, in this way, long link. Like for example, just like the structure of a soap molecule. Here the tetrapyrrolic head is there, and from there chains come down, hydrocarbon chains. Now when you will imagine this tetrapyrrolic ring with a hydrocarbon chain like this coming down, this is what? Chemistry class? No, this is structure of chlorophyll. This is structure of chlorophyll. So remember, how is the structure of chlorophyll? The structure of chlorophyll has a tetrapyrrolic head like this. Like this, a tetrapyrrolic head is there, where Mg is there and pyrrole ring is here. Okay, here two rings are there, and from there, from this fifth ring, the fourth ring, tail comes down, which is a hydrocarbon chain. Okay, so this is the structure of chlorophyll. Just hold on for a second. Just hold on for a second. Look at this structure. Draw this structure if you want to draw this structure. Now if anybody asks you that what is the, okay sir, fine, we understand that if you draw again, then this becomes your magnesium atom, and from here nitrogen. So these nitrogen are part of tetrapyrrolic ring with hydrocarbon chains coming down, and here two pyrrole rings are there. Here also one pyrrole ring is there. This is nitrogen is present here. Okay, here also one pyrrole ring is there. The pyrrole ring is there. Now if this is the situation and hydrocarbon chain is there, a lot of, what is the formula? The general chemical formula is generally C55 H72 Mg N4O5. Yes, pyrrole, Pyrrole, pyrrole ring. Okay, so the pyrrole ring or the tetrapyrrole head, this is known as the tetrapyrrole head, and this is the, what we can say is the hydrocarbon tail. Okay, so that is the structure of chlorophyll. And you know what these bonds are known as? These bonds are called organometallic bonds. These bonds are called organometallic bonds. Okay, and as you know that always remember chlorophyll are insoluble in water. When we understand that chlorophyll is the one which traps light energy, when we understand that chlorophyll is the one which traps light energy, the light energy is being trapped due to the presence of magnesium. Light energy is trapped due to the presence of magnesium. And also this also supports, but these are the, it forms a mat like structure. So this is the details of the structure of chlorophyll, as I would like to say. Now moving forward with our discussion, when we know that what is the structure of chlorophyll, just that one thing that I would like to say you is that there are various types of chlorophylls. There are various types of chlorophyll. There are various types of chlorophylls. Okay, so there are chlorophyll A, CHLA, chlorophyll B, CHLB, chlorophyll C, chlorophyll D, chlorophyll E. Then A, B, C, D, E is there. Then there is bacteriochlorophyll. There is bacteriochlorophyll. Bacteriochlorophylls example is bacterioviridin. Bacterioviridin. Okay, they have their own structures. Okay, if you want to know what is the name of this side chain, I have told you this is a hydrocarbon side chain. The name of the side chain is known as phytol. Phytol side chain. Phytol side chain. Remember, the name of the side chain is known as phytol, means it contains alcohol group. Also remember that it contains alcohol group. Okay, so this is also a phytol side chain. Anyway, now moving forward, that chlorophyll A, B, C, D, E, and okay, these are the types of chlorophylls. Also, apart from chlorophyll, there are pigments like carotenoids, phycobilins. These are also what we can say is supportive photosynthetic pigments. So you should remember this thing. Okay, so this is what it is all about. So now if anyone asks you that, sir, how is chlorophyll A, B, C, D, E different from each other? Definitely they are different from each other because of the change of certain molecular structures. Is it buffering still? Check. Is it still buffering? Please check. I think it is your net problem then, Suraksha. Okay, hold on. Now, moving forward with our understanding that, fine, that we understood that, okay. Now, how is, the question that I had asked is, how is the chlorophyll A, B, C, D and E different from each other? Definitely the difference is in the structure. How is, again, bacteriochlorophyll? I hope the name suggests bacteriochlorophyll, the chlorophyll of the bacteria or chlorophyll of the photosynthetic bacteria, that is bacteriochlorophyll. Okay, so how is this and these all chlorophyll different from each other. They are definitely different from each other due to the change in this certain small molecular structures. Okay. Suppose, for example, one example that I can give you is, if in case of this place in the second ring, if you notice the second ring, if in the case of second ring, here is a R group in the second ring here. Okay, if there is presence of chlorophyll, if the R group is CH3, then it is chlorophyll A, and if you see chlorophyll B, the R group will be CHO. Okay, so that is one difference of chlorophyll A and chlorophyll B, or structural difference of chlorophyll A and chlorophyll B. Now it is found that the chlorophyll A and chlorophyll B differ structurally only here. Rest all the things are same. So it is obvious that all the differences I will not mention here, and which is not also in your syllabus, but I can say that okay, fine, this chlorophyll A, B, C, D and E, they are different from each other due to the structural differences of the the structures, due to the structural differences of the chemical assembly of the molecules in the chlorophyll. So that is the thing. However, there is, you should learn difference of chlorophyll A and chlorophyll B little bit in more details. So at position R of second pyrrole ring, R is equals to CH3. At position R of second pyrrole ring, R is equals to CHO. Okay, the color of chlorophyll A is bluish green, and the color of chlorophyll B is olive green. Okay, fine. Then moving forward, in reflected light, it is seen red. Okay, or it reflects red light. Or in reflected light you will see it to be red. Okay, same thing. And in this case, in reflected light you will see it to be brownish red. And in transmitted light, you understand what is the meaning of transmitted light? In transmitted light, what happens is that if you put chlorophyll solution here and the light doesn't reflect and go, if you put chlorophyll solution here, the light transmits and go. That is known as transmitted light. So in transmitted light, you will see it to be green, and in transmitted light, you will see it to be yellowish green. So this is what you should understand. Okay, so yeah, obviously this is the difference between chlorophyll and chlorophyll B. If you closely look into the difference of chlorophyll A and chlorophyll B, you can see that due to the structural difference, there is difference in the color, and there is difference in the behavior of which wavelength it is absorbing, which wavelength it is releasing. Like for example, you see, when they say that the reflected light means it is not at all absorbing that light, it is reflecting. But in transmitted light means it can pass through the chlorophyll solution. So this tells us that a red wavelength he reflects back, bounces it back, and cannot absorb. But green wavelength or yellowish green wavelength, it can absorb. That's why transmitted light shows us that to be this color. So depending on the structure, what is the structure of the chlorophyll, depending on the structure, we can understand the absorption, or we can understand that absorption of the particular wavelength or the frequency of the light varies. So these chlorophylls are different from each other in respect to the structure, and not only that, in respect to the color, what color they show in the transmitted light, what color they show in the reflected light, where are they present mainly, and also what is the range of wavelength which it will absorb. And hence we will know that in which range of wavelength the presence of which chlorophyll gives us, highest amount of, or highest rate of photosynthesis. Now tell me in comment section that did you understand up to this much? Tell me in comment section that did you understand up to this much? Please tell me in comment section that did you understand up to. No, not how CH3 and CHO. If in the R position CHO is there, okay, then you will call it chlorophyll B. That becomes chlorophyll B. If CH3 is there, then you will call it chlorophyll A. That is just the structural difference of chlorophyll A and chlorophyll B in this entire thing. Okay, and due to this change in this small structure, see, there is difference in the reflected light, color, and the transmitted light. Means which wavelength of light it is trying to interact with, which one it is absorbing, which one it is releasing. Okay, so that is what I am saying, that this affects the structure, affects the color, and hence this different chlorophylls are different in their structure, and difference in their color, and difference in their absorbance of a particular wavelength, or reflection of a particular wavelength, right? So that will determine that in which wavelength of light is the most absorbance there, and hence the rate of photosynthesis is high. That is what I wanted to mean here. Did you understand? Now tell me. Ritika, please tell me. Ritika, please tell me. You understood or not? Okay. So, anyway, so today I wish to take an extra class because today thank you. Today I wish to take an extra class because yesterday I taught a little bit less, 50 minutes. So today I took a 30 minutes class because I wanted to make up for that. However, you will keep on receiving videos from now on. I will try to complete this because DPS has their exam. Other schools also have. I will try to, as fast as whatever classes you have missed or whatever has happened. I was little bit sick and I was not well. I was not in my form, as all of you know, but slowly I am getting back my form, and definitely I'll make up for all the classes. So yesterday's class it was little bit less, I have given now. So today, up to the structure of chlorophyll only I would like to discuss with you. Tomorrow we have a normal class, and in that normal class I will discuss more with you in a detailed